Hi everyone, I'm Nguyen, and this dissertation is to create a new direction for building and developing tube houses that is accessible for not only design professionals but also for general public. What is a tube house? Known for its vibrant urbanscape and trademarked by its narrow facade and long in-depth, tube houses are the main housing topology seen in Vietnam and makes up 60% of housing stock. Although these homes are an important part of Vietnam's culture and economy, it compromises people's well-being. This issue broken down into health, flexibility, and affordability limits the tube houses from being economically and structurally long-lasting. Today, tube houses respond to the current market demands, but at the cost of long-term environmental and cultural degradation. Tube houses still hold important environmental and cultural values, and that is current misfits with Vietnamese climate and traditional family structure can be corrected without compromising contemporary expectation of urban living. Reinventing tube houses would leave it capable of integrating the past and the future in the form of cultural tradition and long-term economic and environmental sustainability. For example, tube houses contain a prominent culture aspect by bringing a vibrant urban atmosphere in comparison to the cookie cutters stereotypical structure of townhouses and villas. The first method is to learn from the past and history. Vietnam's housing typology evolution is highlighted primarily through the placement and the shape of the courtyard. Traditional tube houses evolved from its initial pattern brought through the French colonization. Concepts of openness, natural lighting, and ventilation are highlighted through its courtyards. Contemporary tube houses have then emerged towards the placing a kitchen and a bathroom within the building, which does not allow natural ventilation. This concept of traditional tube house can be applied and advanced within the current Vietnamese architecture. Precedent studies bring modern influences to developing a design language. In the continuation of improving indoor air quality, thermal comfort, reducing energy consumption, and supporting the Vietnamese family structure and urban order. These studies analyze the forms of housing that were successful in those areas in ways to advocate for creating healthy indoor environments. Tube houses can incorporate natural lighting, ventilation, and green facades. These concepts are further extracted and compiled to create a design language catered for those housing types. Designs such as Stacking Green by VNT architects utilize the green facades as a means of air filtration as well as increasing thermal comfort. Key aspects taken from successful modern tube house designs are then strung to create the design language. This language is broken down into structure, roof, floor, walls, stairs, indoor gardens, stack openings, and balconies facades. In this, design principles are then formed with the goals aimed toward flexibility, sustainability, and affordability. Flexible designs includes adaptive spatial and structural system and develops a strong cultural identities. Then paired with sustainability, this can be done by incorporating designs into nature and creating a healthy living space with minimal environmental impacts. Finally, affordability will also make these accessible to a larger population through mixed-use practices, cost effectiveness, and a creation of walkable communities. Design guidelines, values, and concepts developed through the design language are applied to the guidelines, a tangible and working function that will help those designing and developing a tube houses. The design principles are translated into four main systems, creating the guidelines, which are spatial system, envelope system, structural system, and infill system. The spatial system is broken down by conditions, and then the modular arrangement of each room, offering optimal consideration of airflow and thermal comfort. The envelope system is defined by the front facade and the roof system. Type of shading and materials are then determined based on the circumstances. For example, the typical facade in comparison to the green facade. Structural system made of exterior walls and beams and columns allow for any combination of materials to be used in conjunction with any modular design systems. Infill systems are divided into interiors, walls, furniture and appliances, and flooring. It emphasizes modular and multi-purpose systems, which in turn supports the flexible designs. The application of these guidelines to conditions will apply to most of tube houses. Different conditions show extremes highlighting the purpose of design language and guidelines. Condition 1 does not contain the service alley, whereas the condition 2 does. These configurations give examples for user in how to apply the guidelines. The configuration implements each system into the tube house design and how it contributes to a healthy environment for occupants. Configuration A uses a stack opening in the middle with a typical built trellis shading for the roof and the front facade. Configuration B uses a middle stack opening but different floor plan and shading options. For example, the fabric shading is on the roof and vegetated shading for facade. Configuration C has a stack opening located toward the back and uses plants for both roof and front facade shading. Each of these configurations apply Venturi effect and stack ventilation principles, but different in floor plans. The optimal shading strategies are the vegetation for both roof and the facades. CFD studies show the greater benefits of the stack ventilation versus cross ventilation in this particular condition. In the high wind conditions, full frontage receives prevailing winds, providing greater air movement. The importance of this vertical stack opening are displayed in the high wind conditions. For the low wind conditions, the frontage at the higher level receives more wind than the lower levels. Stack ventilation also works under low wind conditions, however, it does not prove as effective. Rooftops will capture the wind as it enters the space, then creates negative pressure. This circulates the air from the outside in. This render shows the configuration A layout with the kitchen located toward the back on the side of the building. Sleeping room and family room located on the second floor. Open floor plans allow natural lighting and ventilation. This shows the ground level of configuration C, where it has a vertical stack opening with open staircase located toward the back of the building. Urban condition 2 with service alley in the back has two configurations, configuration D and E. Condition 2 primarily focuses on modular design and prefabricated process, where units can be assembled at the site. Both configurations use precast concrete at the bottom and steel frame at the top. Toilets, appliances, furniture, floors, and walls are modular. Configuration D is single family home that is multi-generational. This configuration contains services and utilities condensed to one side of the building, creating an open floor plan from one end to another end of the house. The first floor has 88 units and a living room, where second floor and third floor has bedrooms and family rooms. Green roof located on the fourth floor. Green facade and green trellis wraps around the building along with the indoor garden, protecting and creating a healthy indoor environment for occupants. Configuration E contains 5 different individual units, this highlighting the flexibility of the structure, containing living space, office space, with a green roof providing urban agriculture. The first level can be used as open market. The second level is living. The design highlights the use of upside-down double T-beam to create a storage space, further contributing to an open floor plan. And the third level can be rented out and used as co-working environment, for example, office and commercial space. The green roof garden provides space for food production, which can then be sold at the ground floor. Overall design strategies implement sustainable practices through the use of green facades, hydroponic farming, indoor gardens, and green walls. This also includes mixed-use practices as well as walkable communities seen in commercial and office spaces and community gardens. CFD studies for configuration D and E show that cross ventilation is the most effective when the service alley is in the back, providing an open path for the wind flow. These studies prove that the open floor plan contributes to increased natural ventilation and overall building a healthy environment. The comparison shows that existing tube house designs lack of natural ventilation versus the proposed tube house designs with the vertical stack openings. This rendering shows configuration D in the living room, ground floor, looking toward the 88 units at the end with internal gardens. Configuration D, second level, standing at the family room, looking toward the bedroom at the end, with open floor plans, foldable partition walls, open staircase, indoor plants, and importantly, the stack opening located in the middle, providing natural lighting and ventilations. This rendering shows configuration E, which is a single family unit. Looking toward the green facades at the end, a storage system on the ground floor offering the open floor plans. Future tube houses have the potential to incorporate a flexible, affordable, and sustainable design concepts. This can be then broken down to the guidelines applying to most tube houses throughout Vietnam.